And so this morning we're going to be showing you at least 6, maybe closer to 8 different stories of what people have done using point cloud and LiDAR. So whether you use our products or not, you will get some interesting ideas as to what this kind of technology can be used for, and maybe you'll be able to figure out ways you can apply it in your own situation. Along the way, we will be looking at a few different techniques and tips that we've learned over the years about how you can accomplish these kinds of solutions. Some of those will involve our products, some of them won't, but whatever products you end up using, I think the techniques that you learned today should be valuable. So we thank you very much for tuning in and spending some time with us. So, who are we anyway? Well, I'm Dale Lutz. I'm one of the co-founders here at SAFE. We've been doing it nearly 21 years. So we're getting old. We're coming up to our 21st birthday, and we've been moving data all that time.
And I'm Dmitry Bak. I'm scenario creation and testing analyst here at SAFE for almost 10 years. And my job is to play with all the cool stuff that is being constantly added to FME.
And many of these scenarios we're going to show today, Dmitry worked hand in hand with a variety of different customers to create. And actually, Dmitry, you wrote the original articles on our FMEpedia that walked through all the point cloud handling, if I recall.
Yes, exactly.
Right. So actually, I don't think we even talk about FMEpedia today, but there is quite a bit of material on there as well. So throughout the webinar, we've got a bunch of keen people standing by to answer your questions, and actually we will be taking a break about halfway through and then again at the end to look at some of the questions and kind of discuss some of those answers. So don't be afraid to ask questions. There's a way to type them in that Stephanie's shown here on the slides, and do that at any time. So just in terms of what we do at SAFE, we make this product called FME, and what it does is we say that it connects different data types to each other or to different files and systems and formats. We allow the data to be transformed on the way through, and lastly, once you've got that all figured out, then we give you a framework for automating that so that you can run it over large volumes of different data, or run it every night, run it repeatedly, whatever your business needs. So inside this Macintosh here, we see we have some input data. Actually, this is one of your scenarios, Dmitry, with the SkyTrain.
Oh, yeah.
Lines and stations, and then we are running it through a transformation and out to some output that's off the screen on the right-hand side. This one was actually making, I think, an interesting labeled map.
Yes.
In an automated way.
Yeah, very simple one, raster map.
Yeah, yeah. So that's just one of the many kinds of things that we do. And actually, just to get a sense of our audience, if you want to, you can go out to your GoToMeetings and just raise your, there's a button there to raise your hand. And if you raise your hand if you are new to FME, if you haven't used our technology, we should get you to raise your hands. So, oh boy, we see quite a large number of you that are new. Well, thanks so much for tuning in today. As I mentioned at the beginning, even if you don't use our stuff, the techniques we're going to be showing today will be useful to be aware of even in other tools. So we do appreciate you joining us today. Wow, quite a large number of you. Great. So thanks for letting us know that. I think with that, Dmitry, we're ready to jump right in. So this is in just about your neighborhood, I think.
Yeah, pretty close, yeah.
So I'll let you talk to this particular story. What was going on?
Well, here our customer from Port Coquitlam had a very simple data set, a few things, building footprints, a point cloud, and an ortho image.
Yes.
Yeah, so here you can see the
These are the ingredients here.
Yes. So, and the customer, Andrew Khan from the city of Port Coquitlam, would like to make the simple 3D model out of this vector model for ArcGIS.
Yes. So again, the three ingredients, there's an ortho photo here on the bottom left, the point cloud on the bottom right, and then these are building footprints.
Yeah. And they don't have any elevation attached to them.
So they're just quite like only business data.
Yes, yeah. So for it's a plain 2D things, and as you can see, we probably could try to extract the elevation from the point cloud.
Yes. So I've just flipped over, and this was the solution that was come up with. So what would you like to talk to through here, Dmitry?
So this is the graphic environment where we define our transformations. That's for those who join us for the first time. So the brownish things are the feature types, so readers that will read the data. You can see here the buildings. These are the footprints coming from a shapefile. Then we have the point cloud coming from the last file, and ECW, it's an orthophoto.
Right. And now you run it through here. Now, ultimately, I think the interesting trick, there's a bunch of things going on in here, but we're trying to create a good-looking, textured 3D model.
Yes. So in order to do that, first we need to know the elevations of the buildings. So, and we clip the point cloud with the building footprints in this clip.
This one down here. Okay. So that's, you can see the building footprints kind of came through here, and they're being, and so is the point cloud coming. Oh, you're splitting out to only get the last return.
Yes, yeah.
That's also important. With these point clouds, we can do things on the first return, the last return, and so on. So this one,
so here we take only the last return.
Yes.
So, and then if you go to this transformer, and this is a new thing in 2015 that might be interesting for our old users, we added statistics for the point cloud.
Yes.
And so in 2014, we would just clip each point cloud and get the point cloud related to that building only, and then we could extract only min and max. So we would extrude the building to the max point within that building, and that could be an antenna or chimney or maybe even a bird flying over. So now we can pick something else like a median value.
Yes.
So which is much better, gives much better representation where the actual roof is. Especially this works really well for the flat roofs, which in downtown Port Coquitlam is the prevalent ones.
Right. So the thing is, this is going to be done for each one of those buildings. We're basically going to get a little point cloud for every building because we chopped them out.
Exactly.
And now for each one we get the median. And so now you put back the geometry, and now this is where you must extrude it.
Yes, here we have two extruders because one extrudes the roof separately from the walls.
Okay.
And why I need the roofs? Because the same footprints were also used as clippers for the ortho image in this clipper.
Up here. And then you're going to put them together.
Yeah, here and here I add the images related to each roof to each geometry of the roof.
Right. And then lastly, you output it as a building.
Yeah.
And now I know that you have, the customer wanted this inside of ArcGIS.
Yeah.
We have a screenshot of that in a minute. But just to show folks, we also can easily output this into PDF. And so here it is as a 3D PDF. And you can see the buildings popping out of the ground here.
Yeah, we didn't have any textures for the walls, but the roofs are nicely textured with, whatever comes from the ortho image.
Right. So again, if I flip this looking from the top, it's kind of like the ortho image, but there we can see it nicely popped out. And so we can make a PDF, we can put it in ArcGIS. If we go to ArcGIS, we can put all the business attributes back on these and go from there. So that's that first scenario that we wanted to talk about today. And so again, here is the result inside of ArcGIS. Oh, because you also, for ArcGIS, you output the point cloud as well.
Yes, so this little transformer down the workspace.
Oh,
yeah.
And you're doing what, we're going to talk about this more later, but you're augmenting the, or enriching the point cloud by adding color to it from the ECW. So this is a point cloud on raster overlay. The point cloud is coming through here, the raster is coming here, and we end up with a colored point cloud. And we even wrote out the last D. If you're an ArcGIS person, it means it can be displayed like that.
Yeah, that's what you need to in order to display it there.
Right. So fairly involved scenario, but once it's set up, you can kind of run this as a cookie cutter type of thing on all kinds of input data and create a starting point for a 3D city model. So what's our key takeaways? I will read the first one since I was the guy that did the math here. I would say 1 + 1 + 1 = 6. So we had 3 different data types. We had our footprints, we had our LiDAR, and we had our ortho, and by fusing them all together, we created both a better point cloud, as well as some valuable 3D output that we could use inside of ArcGIS and ArcScene, and eventually the Pro app, because it would be a nice 3D thing. And
and point cloud statistics calculator is a new transformer which allows statistical calculations on point clouds, and you could see that using median value is that's where we got our advantage for get a better, more reliable, realistic building heights.
Yes, when we know the buildings are flat, then this gets us a truer representation.
And if it's not flat, then it's approximately, well, pretty good. In any case, much better than the max value.
So even if you don't use FME, there's a couple of tricks here to be aware of that you can somehow or another find tools that let you fuse different data types and create better output. But also, if you're doing these kinds of almost feature extraction, statistical approaches can give a better result. In the past, Dimitri, you've done other forms of chopping things vertically to throw out spurious, like if birds are flying over, by techniques like that to try to basically slice everything vertically and then throw away these slices that have almost no data.
Yeah, we will show this later.
Yes, but the statistics calculator is a smooth.
Yes, it's a very good, good addition.
All right, so from looking at roofs now to looking at the tops of trees. And I don't know if there's a koala bear actually where there is a palm tree, but and British Airways. We've got all parts of the world represented, I think, on this picture. So let's look at this. So we got actually we found this to be a fairly common scenario. People have flown LiDAR somehow, or they have LiDAR, and they want to know something about their trees. And so this first example is from our friends that run a small airport. I think it's actually National Defense here in somewhere in Canada, and they need to make sure that the trees aren't getting too high at the ends of runways. So what they want to do ultimately, the desired output, is a map like this. They were actually using map info as the output, where I think that the reddish stuff is what needs to be cut. Is that what you think?
Well,
green is good?
Green is usually good.
Green is good. And so in any case, they're producing a square pixelated map to know where to dispatch the tree cutting crews. Yeah. So that's the problem we're trying to solve. We don't want trees growing up at the end of runways. It looks like a tent. People are tenting out there, camping on this runway. So that's the idea. And so, Dimitri, you want to walk us through how this one works?
Well, this one, here we have only a LAS file as an input. Here we have point cloud filter, which
this one is bringing
it says filter crazy points. Basically, that's probably there is nothing higher than 75 meters in their data set. So if you have any points above that, then you probably don't need them.
So we get rid of the
birds or planes.
Yes, yes. And now we go into something that's going to pull out. This was classified LiDAR, so we can pull out the ground and we can pull out the high vegetation. The two things.
Yes, and after that we create a DEM model from each of them.
Yes.
And then we send everything to raster expression evaluator,
which is going to compute the difference.
Yes, you can make all kinds of things from two rasters, just some kind of math.
So let's just, again, the key thing here is that we've split the LiDAR into the top and the bottom, basically. We're going to make a raster DEM. So now we're converting the problem from a point cloud problem to a raster problem at this point. And now we're going to have two DEMs, one representing the top, one representing the bottom, and now we're going to just take the difference.
Yeah.
And lastly, now we go from raster land out to vector land.
Yeah.
That's what this is doing. We're creating a polygon.
So, and each cell, will have the attribute representing the difference, which is the value, the height of the trees. In that cell.
And so once we have that, now we set colors. This is a lookup that says height to color, and then out we go and output it just like that. And we also have saved it as raster too. We saved it both as a vector and a raster in this case. But this was sufficient, this workflow, to allow them to run this on all their scans of airports across Canada and determine where there is vegetation that might need a visit. The other thing we didn't mention, this is creating an area of interest around the airport. So if the scan goes out further, we don't care about that. We're just labeling or working on an area that we care about.
Yeah, well, anything can go into this port. So if you have your areas of interest represented with some vector
Yes.
data, it can replace this creator transformer.
So again, key takeaways.
Well, we can easily split your point clouds by a number of parameters or components, how we name them. So in this situation, we split the point cloud by class. So and this transformer is green. It means that it's a custom transformer, well made by me.
Yes.
Basically, I just use our point cloud splitter, which adds an attribute to each point cloud. Split point cloud, and then just I mark as an additional attribute.
Whoops. And let me go back. This point cloud filter is also used. In this case, we were throwing away crazy points first, so we can kind of weed out some bad ones. And now, lastly, when we're in raster land, we can bring to bear some raster tools. So this tool here took the point cloud, made it into a raster DEM, and now we can do our arithmetic in there.
Yep.
So the net result is you know where to go and cut down trees. So that's one kind of tree canopy example. Now this one comes from our friends in Johnson County, Kansas. Aaron, I think Aaron might be on today, and we could ask him questions, put him on the spot if we wanted to. But he had the task of needing to update the county vegetation map. And actually this customer story was presented at a conference in the US somewhere, and we can actually share out Aaron's slides. He's been good enough to put them online. And so if you're interested in the details of what he was up to, maybe I'll even get Stephanie to chat that out if people want to. You can take a look at the full set. Oh, there it is. So we can also chat that out. But the interesting thing about this one is that Aaron used quite a bit of ArcGIS geoprocessing up front to do some of the early grinding. He solved much of the problem in vector land. In our first example, we quite quickly went to raster land. This one, he used an ArcGIS geoprocessing tool to go last to multipoint, and then he did an aggregate points tool. That's what this is sort of representing, to try to snap polygons around LiDAR first returns. Then he used FME actually to remove spurious results and remove spikes and so on. So it's a combination of the two working together and being held together by Model Builder to do this. So again, the full details are there. The one trick here, or the one thing, is that by doing it all in vector land, because there's a lot of data volume when it comes to LiDAR, it was relatively slow. I think it took him 6 hours to do that aggregate of points across, and you had to break it up into, I think, 8 different tiles to do that work. So again, tiling the LiDAR, make the problem smaller, then throw processing at it, and wait was at least one thing to be aware of. Again, the full details of that are over there. So what do we have for some takeaways, Dimitri?
So, well, ArcGIS and FME, we are, well, good friends, and FME can very easily, well, it can easily work with ArcGIS or even within ArcGIS.
Yes. And so by combining the best of both worlds, they were able to get good results. Staying in vector, which they did in this case, they never actually went to raster. They did the whole thing in vector land, points shrinking around it, results in longer processing but no little jaggies. You don't have any pixelated look, so you get nice looks there. And the tools inside FME to be aware of are both the spike remover, and we have quite a lot of options in our generalizer that can be used to smooth, to kind of add a more natural look to the polygons.
Yeah, usually we use a chain of generalizers. One would simplify, another would smooth, third would, well, make some other tricks.
Yes. So if you're not aware of those tools, and then in this particular case, he was not creating a complete coverage. In other words, we were just getting individual polygons sitting around. Some of the generalizer options are for sharing boundaries, so that when we smooth, we share boundaries that are adjacent. He would not have had this situation here. But that's a good one, and so thanks, Aaron, for sharing your work with us. And now the last one, very similar to our friends from Kansas, but this is to Calgary, the place that might win the Grey Cup this year, since everybody else is injured, even if they just survive. Anybody from Calgary on board that's a CFL fan can challenge me or to take my congratulations, but I think they're going to win. Yep. But nonetheless, they'll know where their tree canopies are when they plan their victory parade. So this was presented at our FME World Tour event in Calgary last April, and we're going to be going all around in April this year to talk to customers and see what they're up to again. So we'll see how that goes. But let's see what they did. Okay, the plane flew, and then all the returns came back. So that's how it works, isn't it?
Yeah.
All right. So again, very similar problem to the previous one. And so Dimitri, do you want to talk to some of these ones here? So,
well, in this situation, the data was not only the last file,
yes,
but also a raster, and not just a simple RGB, but RGBI. So near infrared band was there, which helps to calculate some vegetation index. Which is helpful for extracting the areas where you actually have some vegetation.
Yes.
So, and again, we can take the first return or the top and combine it with the vegetation index. So to make sure that it's really vegetation, we can make sure that we actually have trees, not something else.
And this one also went to raster, didn't it?
Yes.
So we took the point cloud. Oh yes, I remember this right over here. This one didn't make, again, it did not make a surface model. It used another tool called a numeric rasterizer, which basically said wherever there's points, I'm going to burn them into cells.
Mm-hmm.
So it's not going to try to interpolate around them. It's only going to put data where there actually was, and then we can use the arithmetic. Again, much like the other one, but what will happen is we've got a whole bunch of cells with no data in them, so those we just can ignore, and then the ones that do have data, first and last return gets subtracted, and then we do a second pass to look at the vegetation likelihood from that image.
Yeah.
So this would have helped Aaron. In Aaron's example, he had to manually go afterwards and remove the billboards and that sort of stuff. This is an attempt to get rid of those billboards earlier. All those Grey Cup victory billboards that are being put up around Calgary already prematurely.
Yeah, yes. And now we can see the result, which is, and here the good thing is that we can compare the manually collected areas and the areas collected with FME.
Yes.
And you can see they pretty much, well.
So these red ones, the red is by
close.
FME.
Yeah.
The red is FME, and the green is what was manually done in this test area, and it's very close. So this is, again, if we want to look at the technique here.
This is not from the Calgary example, but that's approximately how we can go from a point cloud or from a raster to vector features. So here we can use raster cell cursor, which turns each cell into a vector polygon,
yes,
or a point, and then we have hull replacer, which would go around the points and make them
shrink wrap them, basically.
Yeah. Make a polygon around them. And then we just can add a few measuring transformers that estimate shape and area, and based on the size and the shape of the polygons, we can conclude whether that's what we are looking for or not.
Right, because basically if they're long and skinny, in this case we don't want them if they're long and skinny.
Yeah.
Very likely. Unless it's a hedge.
Yeah, if it's long and skinny, it's probably a fence or something. Or
yes.
Yeah.
But sometimes we're actually looking for road center lines or something. Then we do like long and skinny.
Yes.
So that's what this thing is about.
Yeah.
And then again, as Dimitri hinted, sometimes you do two generalizations, one after the other. One to get rid of some of the points.
Zigzaggy look, which you get from a raster.
Yeah. And then this one would smooth things out with different parameters.
Points, so that you don't have.
And then just to
look.
The same thing can be done by, instead of starting with a raster, if we use a point cloud cursor to put in point cloud and then out comes points, we can end up doing this whole same technique. And lastly, the trick here was bring in some other intelligence in the form of, in our case, of 4-band imagery, so that we can do more removal of incorrect results, so a human doesn't have as much work later on.
Yes.
Okay, so I think we're done looking at trees. Time to go to trains now. So we've done planes, we've done trains, or we're about to do trains, and if we're lucky, we'll do some automobiles yet today. So this is to do with trains. Canadian National rolling by. And so the problem that they had to solve was to accurately map train track beds from LiDAR scans. And so they got scans of LiDAR, and they want to map these beds really accurately. And so the issue is you got scans that look like this, and you need to get them down to this, because this is a lot of data. And frankly, the issue in this particular project was that the tools they wanted to use to do the analysis afterwards were croaking on the large data volumes from the LiDAR scans.
Yeah, basically, if you have billions of points, then not that many tools can handle it.
Yes. And so the trick is to do some subsetting. And so actually, I'm going to go over here and show this example here. Is this LiDAR subsetting? Yes. So let me just zoom this up a little bit. Now, this is not the workspace that they used, but I'm just wanting to show the technique. So in this example, I've got some roads and a point cloud. I'm actually going to run this while we're talking here. And so this is just picking out Highway 33. You must know this highway, Dimitri. It's your example. And you pick out one road, and whoa, now we're already done. So let me just flip back to this. So while it was running, it was putting these numbers by, but we picked out the two segments of the road, joined them together, and I've output them to a road of interest we'll see in a minute. Then I buffered around that road, or in these train guys, they would do this with the train track, buffer around that, and then take all the LiDAR that I had coming in and clip it to anything that intersects that road buffer. Now that I've got it, I glue it all back together, and then I would output it here into possibly one or even a set of output files. And I've actually also run it to my viewing tool, something called after. So I've got before, here's the whole LiDAR before, and here it is after. So now let's take a look at it. And here we are, got the background map on. Thank you, MapQuest. So let's turn off all the stuff. So this is the part of the world that we're in, and the road that we were looking at is right here. I don't know, can you see it if I flip it off and on? Yeah, you can in the middle there. Yeah. Okay, and so then if we look here at the before, this is the data that was sitting there, and if I just select that, it's this one here, and I can see that it has over 2 million points in that whole thing. So if I turn off the before, and instead I go for the after, now I see I've got this little sort of cigar-y shaped guy, and if I select it, I can see that it only has 400,000 points. And so that's really the value. By doing this, now you can go into Civil 3D. I think in these cases they were using Civil 3D and Map 3D to do their modeling and analysis in their work. So now they had a much smaller, easier data set to work with. And again, this transformation could be then run over and over again in an automated way to basically chop up and pull out all of the
any incoming data.
Yes, all of the trains and maps of Canada. And by being clever about how we output it, we name it correctly, and bang, we've got our work done for the whole of the country. So that's the idea, subsetting. So again, the takeaway, clipping LiDAR cleverly reduces the data volumes so that you can use some of the other interactive tools you might want to use more conveniently.
Yeah, and at the end, if you go maybe back to the screen, no, to the
the other side, yes.
Yeah.
Let's go like this. Whoops. Is this it?
No. The output here we no
this one.
Yeah, here we see the TIN model. So that's another output that we can generate. So we made rasters, we made vectors. Here is a TIN model.
So that's what some cases do. That they subset and then make a TIN of the subset.
Yep.
So that can be useful too. Okay, so I guess again there's the takeaway. And oh, Dimitri, you wanted to talk a little bit about pole extraction as a bonus here.
Well. This customer, they're working on extracting assets along the railway tracks. So that's an experiment I made trying to extract some poles for another customer. So in this situation, I maybe just quickly mention the technique I use.
Yes.
I tile the whole point cloud into small tiles, maybe say 3 by 3 or 2 by 2 meters. And then I tile it vertically, so I get the stacks of boxes.
Big cubes. You're basically making cubes.
Cubes or maybe
It's a Minecraft world.
Pretty close, yes. And then I count how many points I get into each box or cube.
Okay.
So and if so, obviously the most points I will have on the ground, and then I see how many points I have in the cubes above that.
Okay.
So if I don't have any points, it means that, well, I don't have anything. So for example, I don't get any wires then.
Okay, yeah, because
into my output. So I just count if there is a gap between, well, the
ground.
Ground and something, then it's not what I need. So
and then you throw it all the way.
Yeah, and if I have a continuously filled cubes,
like column.
Yeah, it means that I have something in there. So that's how I extracted.
So the trick there is temporarily, not on disk or anywhere else, but logically chop it up into tiny little cubes, your space.
Yeah.
And then once you have it chopped into these cubes, do some analysis to see where are their columns, basically.
Yeah.
And so that's another trick.
Yes.
And then throw away everything that doesn't have a column.
Yeah. And from that, we already showed how you can go to vector features. So just make a polygon around it, replace it with a point, and you get your point.
And now you got like a 2D point. You also can keep these various artifacts so that an operator can quickly look at them afterwards. So that's kind of another technique. Again, to recap, use a tool that lets you chop stuff up into small little cubes, and then take a look around inside them, and then throw away the stuff you don't like. So that's a trick there. Oh, we're supposed to do some Q&A. So I hope that our team has been busy asking lots of questions or answering questions. FBX. Somebody asked me if we can do FBX. I happen to know that the Filmbox 3D format is close to done on a developer's desk out there. So it may not make FME 2015, but it'll be very short. So Maxwell, yes, FBX coming soon. And what about texturing walls? So when we extruded those buildings, could we? It's actually Bob. And hi, Bob. I actually know Bob that's asked this question. We've done this before, where if we can randomly texture, if you know that the building is sort of industrial.
Yes, we ran some analysis by measuring the building area, building height. So from that we can conclude whether it's a residential, maybe industrial or commercial real estate, and then we have a set of textures related to each of these groups, and then we can randomly texture the buildings.
So they're not exact. There is one example Dimitri did years ago from where was it? The town of High Level or someplace in Alberta. That actually had pictures of the front. They had the building footprint, LiDAR, and a picture of the front of every house.
Yes.
And so in that case, we could actually use an ID off the building to grab the texture of the front. So you need good input data, though, to do that. So how do we line up the data? We have to be sure that it's been properly reprojected. Coordinate system is a big deal in these things. So all the data has to come from a known coordinate system, and then we can reproject it so it lines up. So that's how we do this. So okay, somebody's asking what 3D models. Boy, what is your favorite 3D output format, Dimitri?
Oh. Well, PDF is very good because it's easy to share with everyone. So I often go to PDF, but well, I go to multi-patches in ArcGIS. You can write SketchUp. Yes,
SketchUp is fun. We are supporting SketchUp 2015 even for people who care about that. Other 3D output formats, OBJ is an old-time classic. 3D Studio Max, Collada. So there's quite a variety. Our friends from Calgary, Yaros asks about the point cloud last classifier. That's a custom transformer that you made.
Yeah.
And we can share that. It should be.
It is on FME Store. Yeah.
FME Store. So if you just search for it, it'll be there.
Just type within Workbench point cloud LAS, and you should get it if you're connected.
So LAS zip, we do support the Esri LAS compression. They promised an API to work with it, and about 3 minutes after that API is released, we will do our best to support it.
Yeah.
So we're anxious to, but we need that one to work. But LAS zip we can definitely do.
Read and write.
Go Stamps. We got a Stampeders fan. I have to admit I'm an Edmonton boy, but I think with their quarterback hurt, we're sunk, so we won't engage on that. You mentioned automotives. Yes, we're going to go to cars in a few minutes here, and we'll see what we can do there. And let's see. Bola. Oh, Bola's asking, hi Bola, we know you very well from Norway. Thanks for tuning in late at night, I'm sure in a cold Norwegian evening. Dimitri, the workspace for pole extraction, we can make that available, right?
We can make that available. Unfortunately, I don't have the source data set.
Right. So we can't make
but definitely, yeah.
We can show you the workspace so that you can look at the columns. So we'll make a note to include that in the send out, or basically the bunch of the workspaces from today will be made available, and we'll include that there. So thanks for asking that. And there we go. So I think with that, we'll go back to our regularly scheduled programming to wrap up. And we're doing automobiles. So we did planes, now trains, and now automobiles. So this one comes from our friends in Hungary, Gula. I don't think I said it right.
Dula.
Dula.
I would think Dula, yeah.
Yes, okay. So sorry about that, but anyway, fantastic work that the City of Hungary is doing. Very, very impressive.
City of Budapest.
Sorry, City of Budapest. Yes, I know it's not a well, the city there, and they actually are looking to even share this technique with others if they want to. But it's been blogged about as well, and we can send a link. But Dimitri, tell us what the task is.
Well, there is such a thing called IRI, International Roughness Index, and they tried to calculate it for based using LiDAR for their roads.
So basically,
it's basically tells how good your road is.
How bad or how good your road is, and if you can calculate this in an automated way, then that helps you to do better.
Yeah.
Figure out where to dispatch crews. Again, at the end of the day, you're trying to make good decisions, good business decisions. So, what do we want to talk about? So it's kind of it's not an impossible workspace, but an interesting one that walks through some things. Actually, I've got it here. Do you want to just take a peek at a couple parts?
I think we should be okay.
We can look here just very quickly. This is this one here. The one thing I wanted to say is this is an example of them using LAS tools, which is a free.
Yeah, this is interesting. Yeah.
Yes, and so I wanted to point to this, that they set up some gateways that pass data from FME land into LAS tools, do some work out in LAS tools, and then bring it back into FME land. And so that's really the interesting technique that they have done, is to use both those tools. Dimitri, do you want to talk to roughly what the approach is? We can look a little bit at what their trick is.
So, well, once they process their data with LAS tools, they bring it back to FME and triangulate it to have the triangles for the surface of the road, and then they just compare the min and max for the triangle, as far as I understand, to see what is the difference, and that gives you the roughness, the deviation from what you would expect, and then they can output it to points, and as you can see, they have lots of cross sections, so that they can then every short piece they can have the points represent showing how good or bad the road surface is there.
Right. So the root of the technique is make lots of cross sections, triangulate, look at min and max, and then once you know where things seem to be deviating quite a bit, then group those together to make your potholes.
Yeah, and you can see that green here represents the good surface, yellow probably not that good, and red might need repair.
Yes, so that's the technique. And so again, the key takeaway, again, FME used to bring in functionality from LAS tools and script it so they can run it over huge data volumes. And that way they can store some of the LiDAR in databases for later retrieval and output the results to formats that are useful for their downstream business work. So thank you very much, our friends in the city of Budapest in the country of Hungary. So there we go. All right, so our friend Tim over at Focus, I think Tim is from Calgary, Alberta, home of the Stan Peters as well. Lots of Calgarians doing stuff with LiDAR. Actually, even his example here, or this example, sorry, it's not his example, Dimitri says, but this example here shows again the value of subsetting LiDAR to be in an area that you want. And so there's two sides to Tim's. One of them is he was doing lots of work reducing data volumes by subsetting. We've actually already looked at that, so we won't dig in so much. But the other interesting one is he was enriching his LiDAR so that he can do other work in point cloud tools later on with a more vibrant data set.
Yeah.
And so
would you like to try to enrich your data set?
Yes. So let's look at this. Where is it? This must be it.
Yes.
Enrichment. So I think I might even go ahead and run this while Dmitry talks through it.
Here we use the same data that we used in our first example. We clip our point cloud for the Port Coquitlam with building footprints. And then we can change the classification for the points that are within the building footprints. So we can set them to class 6.
Yes, so we basically...
Which means, in last terms, means the building.
So we are applying the vector intelligence by clipping out little pieces and then slamming and setting the this classification. We now have, and we'll have had 64 point clouds will have come through there. See, 64 point clouds came through.
So, and then we also add another trick. So in this case, our first enrichment was with vector data.
Yes, that's this part here.
Yeah. Then we enrich our point cloud with some color coming from the ortho image.
So this is the point cloud on raster component setter. So it's basically pulling pieces from the raster, the color, and putting it on the point cloud.
So whenever a point falls over a pixel, we just look at that pixel RGB value and take it back to the point.
Yes.
Could you open that transformer maybe again and change this parameter, or show that we have that you can not only set the color, you can set just about anything. You can have a raster, for example, with some zoning, and you can change you can set your point cloud components to zones or anything.
Yes. Basically, we're making the point cloud richer. That's why it's called enrichment, I guess. And then at the end, we could output it as a LAS file. Now, I just routed everything to a viewing tool. Again, you can see the numbers working. 64 buildings went in. We clipped them. There were 64 buildings inside. We slammed the classification to 6 on all of those. And then we took those 64 plus the one that represents everything outside and combined it back into one big point cloud, and then one image went in here, one point cloud, and we get one coming out. And so, yeah, that's the deal.
Yeah, let's have a look. What we have.
Let's take a peek. So this is the. Let's look at the before. So here we are before, and if I just zoom in a little bit, there it comes in, and if I go and click somewhere. So if I go even to the top of these buildings, you can always see that the classification was always 1. Yep. This one didn't know anything. And if instead I go to the after, okay, first of all it's colored, and there it's kind of coming in more nicely. If I look at some of these guys that are on the top of buildings, oh, it's still thinking. There we go. So did we get it? Yeah, classification is 6. But if I go out onto the train tracks, I better hope that the classification stays as 1. Oh, and by the way, look, we've got the color red, green, and blue as well. So that's a nice enriched point cloud. And if I'm really daring, I can try to tip it up. I think maybe you're going to take away my license now. There we go. So we can see that that we have it there, and it's got some height to it as well. So that's our point cloud that's now been enriched. So, key takeaways. Use all the data available. If you're going to do work with your point cloud later on, use everything that you have at your disposal to make it as good as possible. We've had other people take vector data that is known to be water bodies and do things like slam the Z value.
Yeah, leveling. So if you by some mistake of measurement have your lakes not entirely, well, exactly flat, you can make them flat.
Or if there was waves on the surface, or people out boating, or whatever,
yeah, so everything
can whack it. So that I know that was an example that people had done in the past as well. So yeah, point cloud expression evaluator to go through and apply math. In our case, we did boring math. We just assigned a constant value.
Yeah, but it can be, you can use attributes. You can use components for calculating values for making a decision.
You can do if then else kind of things on a point by point level, and it's super fast to do it down at that level. And then point cloud combiner to bring things back together after you've broken them apart. Yeah. And of course, clipper is always handy to split things along the way. So that's the kind of idea. Enriching point cloud data. Why would you do it? Because you want to use that point cloud in tools like, say, Point Tools or MicroStation or AutoCAD, some of those tools to do other work later on. And might as well have the best possible point cloud. All right. So now we get into the bonus question where we're going to try to run Minecraft here, which could be, I think it's the first time I've done it on a webinar. And I don't know what I'm doing, and my son is in school, so we're going to have some fun. But Dimitri, talk to us about this one.
Well, it looks like Minecraft is a big deal.
Yes.
We probably underestimated it at the beginning, but we see a lot of interest around writing Minecraft. So real worlds, real data, real boring data coming to Minecraft can make it not that boring.
Yes.
So can you imagine the excitement of all the kids in my son's classes when my kids say that? Well, our dad plays Minecraft for a living.
Yes. I know when my son, his kindergarten class had Bring Your Parents to Work Day, the other guy was, one of the other parents was a chef from the local hotel. He came there with a big propane torch and made creme brulee for them all. I didn't even want to go. Oh, I make a map. But now I could go. This would be at least as cool as making creme brulee. Okay. So this is an interesting cartographic example, and we're working with Roger Johnson, who's the chief cartographer of the U.S. Parks Service, National Park Service, and he's given us a bunch of data of roads and trails and so on. And Dimitri is doing some work to take this data. And why are we even talking about Minecraft in a point cloud webinar? Because really, Minecraft is based on 1 by 1 meter cubes. It's a well-behaved point cloud where you can imagine the points to be the center of those cubes.
Yeah.
They're voxels, really. But voxels really are regular point clouds. So what we're doing is taking all this
vector data and DEM model.
Yes.
And then, well, we can go directly to a point cloud because we have point cloud combiner which would turn into a point cloud just about anything.
Yes.
A raster, a vector, a 3D model can become a point cloud. Well, but in this case we go through rasterization, so just to make all the vectors well behaved.
Yes.
Yes. So, and then we just simply set block IDs, whether it's if we read shapefile of rivers, we would like to make all those things or blocks representing river and so on.
So I think I've got it here. We won't run it, but this gives you an idea. It's the same workspace. So Dimitri's made a Minecraft styler that can let us find all these different kinds of Minecraft objects. Like for Christmas, I see that I could use coal here. I saw a bunch of hard block of coal to give my kids. I can make a Minecraft world of coal. So anyway, you got everything you need. Oh, there's different even kinds of coal, I guess. So, and then some of them you offset as well.
Yeah, if you have a sapling, you would offset it by 1 above the ground, and make sure that you have some grass or podzol under that sapling so that it grows. Otherwise, it would just die.
Right, right. So we can plant trees more effectively by using this. So here's, I guess you're making the roads, the trails, and so on. And then actually you are going to a rasterizer to basically make you 1 meter.
Yeah, make 1 meter spaced raster.
Yes.
And then I go to a point cloud. So out of this coming actually the point cloud, not the raster. So
yes.
Inside I rasterize it, but then I still make a point cloud.
And then you can go and output it to Mount Rainier. Now, here's where our game gets interesting, literally, because I'm going to try running Minecraft, and we'll see how this works. And we can wander around in here just a little bit, looking at Mount Rainier. So I think with going over the, my sons are making fun of how slow my computer actually is for doing Minecraft as well. So here it comes. So if you have a faster computer for playing games, you can use this as a reason to tell your boss you need a faster computer. So we'll go to Mount Rainier. Last night when I was trying this, the rain was falling and it was not so good in there. Here comes the terrain, and in a few seconds we should see, there we go. And so I don't know really what I'm doing. So if we look around,
but at least you can see planted trees, and we can plant hundreds of thousands of trees. That's the advantage of using FME.
Yeah, it's effortless to plant
yeah,
trees.
and if you need some bone meal for make them grow fast, again, with FME it's much better than if you go in actual Minecraft world and would try to, well, put some bone meal on top of the trees. Well, probably only the fans of Minecraft would understand what I'm talking about.
Yes, but now, this is some of the glaciers, I guess, or the snow-covered parts of Mount Rainier. And there's water in here, you can see.
And some trails.
Yeah. And the music is playing, the quiet, nice, relaxing Minecraft music.
It's a sunset.
Okay.
This is the sun going down.
The sun's going down on Mount Rainier right now. So, and actually the sun is going to set in our webinars soon too.
Yeah.
So perhaps we should should I end Minecraft like that? You get the idea. And what is that I see over there?
It's moon rising.
The moon is coming up. I just want to kind of take a moment to relax and enjoy. It's very peaceful here in Mount Rainier today, so it feels bad, but I'm going to end it just like that. So again, that's just kind of for fun, but we can take things like building models, turn them into point clouds, decorate the various parts of that point with glass and other things. Actually, I could show that. Maybe I should start Minecraft again. We have another example. Is it coming back up? Whoop. I think maybe I've exhausted my license for the day. Come on, Minecraft. There it comes. We've taken an IFC model of the safe office and
SketchUp.
Sorry, SketchUp model. Good thing Dimitri's here to correct me. Getting cities mixed up and data formats mixed up. I must be rusty this morning. Okay, and once this starts, we'll go back into single. Look, it says it's cooler than Spock. That's why we need to be using this as mapping professionals. Okay, the safe office, and within the safe office, we can wander around and explore the building. And some of our friends in Denmark and Sweden have really pushed this a lot further with different towns and so on. Boy, I don't know, Dimitri. I might have pushed my luck trying to run Minecraft. Oh, there it is. There we are. Oh, I'm inside the safe office.
Well,
now,
no inner walls though. But
it's a big. We moved to an open office plan. Whoops. So if I wiggle around in here, whoop, back to game. How do I? If I want to get out of here,
just break the window.
Are we allowed to? The landlord might.
I won't tell anyone.
So how do we do it? Oh, and then how do I get out?
Break one below.
How do I break it below? Look
just
down.
Yeah.
Okay. Now can I go out? Okay, I can go out and look around. So there's a safe office for you in Minecraft. So that's about all we'll do to that. So let me end that. And I think that pretty much does our webinar in. So here's a nice shot. You did this on your computer where you can render better. A shot of Mount Rainier, and we look forward to doing more parks this way. So what are some of the takeaways? Would you say?
Well, we used to say point clouds are raster gone wild. Now we have well-behaved point clouds with Minecraft. Well, but the key takeaway that, again, any data can come in, we can change it to any type of data, and it can get out.
Right. I think maybe, whether you use FME or not, this idea of not allowing the type of data to constrain you. To say that, a friend of ours said that really data should be considered as fluid, so you can mold it and pour it from one vessel to the next. And that's really what we did in many of these examples. We were pouring data that was raster into point clouds. We were pouring point clouds into vectors. We were rearranging to solve ultimately a very important business problem, whether it's figuring out where to cut down trees or impressing your children. These are all things that can be done when we recognize that our data is malleable and we should use whatever tools we want. Today we showed ArcGIS, we showed using FME, we showed using LAST tools. All of these things have their strengths and weaknesses. We talked about people using MicroStation as their tool afterwards, Civil 3D, MapInfo, ArcGIS. Doesn't matter. They're all places that are good destinations, even PDF, and frankly, even Minecraft.
Yeah.
So wide ranges of things. Oh, we do have one poll. So now that you've seen all this stuff, what is it that you would see yourself doing? So I'm going to launch that poll. You can choose more than one answer, and let you think about that, and then we'll look at some of the questions that have been coming in as people are answering there. Yeah, somebody's asking about voxels. What about aerial versus terrestrial LiDAR, Dimitri? Would you say there's we don't care, do we?
Well, no.
Right. It's really all the same. Yes, we can do geoid corrections. We can do adjustments. People are asking, what about if the elevations are measured off of the wrong geoid?
Yeah, we can do that. Yeah.
That's not a problem. What about over 100 and 200 gigabyte file sizes? You want to talk about file sizes for a minute?
Well, I didn't try 100 gigabyte file, but I tried 45 gigabyte maximum, and well, that was fine. Yeah.
Yes, we put a lot of work.
Yeah, we definitely can read, reproject, tile it. So basically, it's still probably it's not the file size with which the end product will work. But FME is definitely good to chop it into smaller sizes.
We've now viewing such a huge LiDAR. I wouldn't say we're good at that. We want to output to point tools. That's one of the formats we support together with working with our friends from Bentley. And so then you can use one of those optimized viewing formats for that kind of thing. Not that. So I'm going to close the poll there, and we can share these results. Let's take a look. Did I share the results? I must have. But basically, feature extraction, enrichment, tiling and clipping is very small, actually. And that's interesting. When we did this years ago, there was far more people that wanted to do that.
Well, you see, it's a very good intermediate step, but probably not your the final.
Yes, it's not really. You don't wake up in the morning and say, "Boy, I want to tile some point clouds."
Yeah, so, but definitely tiling is very good technique for making your work faster.
Yeah.
Tile it, process it, combine it.
Yes. So let's take a look. Oh, we did the Q&A. How are we doing for time? We got exactly 1 minute left. And if you have missed some of our past webinars, we did a MicroStation webinar about a month ago. So you can look at some of those in our safe.com/webinars as well. And there's training all the time. If you go to safe.com/training, you can check that out. Let's look some more at some of these, the 64-bit help. Yes, because we can then make use of much larger amounts of memory for caching of point clouds. So please use the point cloud when you can. Some people have mentioned X3DV as a point cloud viewer. There's lots of free point cloud viewers as well that do very good jobs. So I would recommend that. I don't know if the quick Q&A panel, do either of you guys want to jump on? We got about a minute left. Mark, Dave, anything that struck your fancy from all the questions today? Some people excited to see some Minecraft. Yes, it's a bit complex to make Minecraft from scratch, but if you take a template from us, and we are actually working to make them easier to do as well. But anything to say about making Minecraft models?
Well, I really expected that would be a bit easier than it is. We really will try to make it easier for the customers. Yeah.
Can we merge LAS and JPEG? Yes, we can merge LAS and JPEG in terms of colorizing, if that's what is desired. Oh, Tim was there. Oh, he's from Victoria, and he's not a Stampeders fan. So sorry, Tim. I put you in the wrong city. Boy, it's a bad day for me geographically. So Tim is probably playing for the BC Lions, and so he's got a pretty tough road ahead, I'd say. So anyway, sorry, Tim, about putting the wrong city, but thank you so much for sharing. That's just one of many things Tim has done. Now I remember his presentation. He was in Victoria, and it was really good. Can we get the transformation matrix from E57? I think it's in the properties. If it's not, we could do that. So whoever's asking, Cedric is asking about E57 as a LiDAR format, and yes, we can get that.
We definitely get it somehow. Maybe not expose it.
Yeah.
But we definitely can expose.
Yeah. So we'll just say goodbye, folks. Thanks so much for spending some time with us today. We hope you found this useful. We hope you got some ideas of ways you can leverage that wonderful asset that you have in all your LiDAR data even further.
Yeah, thank you much. Thank you very much, everyone, for joining us this morning.
All right. Goodbye.